We are talking about this paper titled Anterior Insula Regulates Brain Network Transitions that Gate Conscious Access. And this paper was written by Huang and colleagues. And it was a very interesting paper. They have set out to examine conscious access, and so they have completed 2 different experiments. In the first experiments, they used a general anesthetic substance, propofol. And so they have created this setup where they increased the propofol concentration. So they examined mental imagery processes, and they examined it on base level without the influence of propofol, and then progressively increasing propofol until the participant reached the level of unresponsiveness. Then there was additional testing during unresponsive state, and then progressively they stopped the propofol infusion and then looked at how the participant recovered, and then again tested the same task when the participants were completely recovered from the anesthetic. So in this experiment, they have examined 4 different tasks, or they used 4 different tasks. So they used the mental imagery for playing tennis, mental navigation, the imagining to squeeze a ball, and then actually squeezing the ball. Yeah, so actually and there was also like restful periods.
Yeah.
And so this was the first experiment, and the second experiment was...
Can I say something before going to experiment 2?
Yeah.
I think it was mentioned in the paper, but the experiment 1 is kind of mimic of the Adrian Owens FMRI like imaginary like studies. So
yeah.
If we can add that information, maybe the listener will be imagine what the experiment will be like. That's it.
Yeah. So basically in this experiment, so in the first experiment, they have identified different brain regions, and mainly the anterior insular cortex. And then for the second experiment, they set out to test whether the anterior insular cortex is actually what is the role of this area in the content of consciousness.
Mm-hmm.
And they used backward masking task. So they showed the participant different faces and scrambled faces with different visibility levels, and then examined whether the activity of different brain regions, and mostly focusing on the anterior insular cortex, if its activity actually predicts the visibility responses. So I think that was that was my understanding of the paper, quickly summarized. And so as you mentioned, Yota, this study was definitely building on the previous work on patients with different disorders of consciousness. So, for example, with locked-in syndrome, when people appear to be completely unresponsive, but they are actually conscious, they are able to do mental imagery. And that is a very, I think, cool approach to actually test whether someone is have conscious activity. And so basically this method was used in a clinical setting, and now it has been used in a completely non-clinical setting to establish the behavioral and to establish the neural correlates of changes in the level of consciousness. Yeah, so that was, I think, how I would summarize this paper quickly. Do you think I missed anything, or would you like to add something?
Well, I think that's fine. But while reading this paper, that word conscious access is a bit difficult to understand. So they clearly mentioned that they defined conscious access as the global ability of sensory information to cognitive processes. But like, it's of course different from access consciousness. But I am a bit confused what the conscious access is. So I think that's the core of this paper. So if anyone can help me to understand this concept, please do so.
As far as I understand that in this study, the access consciousness means the translation from the audio sensory to the mental imaging, or like the scoring the ball. So in this study, from the sensory input and to the like the mental motor image or mental motor control. I understand, as far as I understand.
Yeah, I think they are specifically actually mentioning that they refer to conscious access as information, sensory information being available to all the other cognitive processes and different brain, like all of the brain regions. So I think it's actually coming from the approach of the global neural workspace theory. I think they also refer to the theory as in the discussion. And yeah, I think in this case they kind of use conscious access as kind of alternative term for this global ignition, or that was my understanding.
So specifically in experiment 1, in that concept, so the sensory information is the audio instruction, not the imagination or the tennis like imagination or squeezing or something like that. So is my understanding correct or?
Yes.
Okay. I see.
So in this study, when the participant have the access consciousness, participant can image, so motor image, motory and motor and do motory. And if not, participant cannot do. It means access consciousness or not, right?
Yeah. So I think in they have I think their console for behavior responsiveness could only be the actual squeezing of the ball as a behavioral response, and I think they use that to establish how progressively or actually when was the loss of responsiveness achieved. Yeah, I don't think there was any feedback, or I don't remember reading about any kind of way of the participant giving feedback about their mental imagery processes during the task. But I think they assume that if the behavior response was intact, then most likely the participants were also compliant in the imagery task.
I see. Yeah, thanks.
Yeah. So in the figure 1, base 1 and for the LOR, and base 2 is the participant have the access consciousness, and LOR is not the consciousness.
Mm-hmm.
So they cannot movery or mental image.
Well, I think this is the assumption, but since I don't know if it has been actually it can be easily tested. Like obviously, if you are not able to squeeze a ball, that I think that's a good marker of you being very drowsy. But I wouldn't be completely certain that these people were completely unconscious. My intuition is that in this kind of general anesthetic admission or during this process, people become more drowsy, and then maybe they kind of fluctuate from wakefulness and unwakefulness. And yeah, I would be actually very interested in seeing whether, they may not have understood the task when they were non-responsive, but I would assume that they may have some kind of mental processes or mind wandering going on, kind of dreaming, or when you're falling asleep, you have this kind of fluctuating of maybe images or thoughts. Yeah, I don't know. I would be interested.
And also, I think the reason why I confused what the conscious access means is probably because I first thought that the conscious access to the content of consciousness, so in the imaginary task, the conscious access to, let's say, tennis, or conscious access to squeeze ball or something. But this is not correct, right? So conscious access to instruction, and then if we have conscious access to instruction, we can do something. So is it correct, or?
Yeah, I think in figure maybe 4, yes, figure 4. So they specifically looked at the time course, and they looked at when exactly the instruction, so at the 0 time course is, or 0 time point is when the instruction is given. So I think, yeah, this is the crucial aspect, or they are definitely pointing that out, that whether the participants were understanding and responding to the instruction.
Okay, I see.
But yeah, I think so in this experiment, so they have looked at specific brain regions that are related to these different networks, the default mode network and the ventral attention and dorsal attention networks. I think it's an interesting idea that I actually haven't mentioned during the summary, that the transitions between the networks is an important aspect of consciousness or conscious processing. And again, they kind of point to the anterior insular cortex as a potential source or a potential modulator of these transition processes. I think that was definitely, an interesting. I don't recall hearing about this idea that much. What was your impression on this?
Well, I feel like the last episode or last week, we read the paper that shows that many, whole brain regions are important for consciousness, and there the default mode network was mentioned. So again, we saw that the word default mode network in this paper as well, and saying that the deactivation of default mode network is somehow important or something. So, in a sense, that's kind of consistent with the paper we read previously. And other than that, for experiment 2, they shows the response differentiated between seen versus unseen. But the face, I don't know, but the face region may not be activated. Or I don't know, they did not mention anything about the FFA or something. So I was a bit, wonder what was their expectation, or did they mention anything about the face area, or maybe?
Yeah, I think they mentioned that there was an activation in the FFA.
Okay.
In showing pre-stimulus effect, But then they also point out that it's most likely not related to the access consciousness. Yeah, because it wasn't present for apparently post-stimulus in the seen versus unseen trials. So it kind of means that, or I guess for them it wasn't a important area to examine further.
I see. Because like in experiment 2, there is no voice instruction, right? So when they say access consciousness, conscious access, it means conscious access to like face or noise image, right?
Yeah, exactly. So I think in that case, you would have the conscious access to the sensory input from the visual area, and then there was the response that was kind of indicating whether there was kind of access consciousness achieved in some of the trials.
So like in that sense, they say that AIC plays important role for conscious access, but they did not mention about the content of the consciousness, right? So if subject perceive face, then there should be activation of like face-related areas in addition to AIC. And if like subject, let's say, listen to some like stimulus, audio stimulus, then the activation of some audio-related to area in addition to AIC is something what they kind of expected. Or is that correct? Or
sorry, I can't understand what you mean. So
like
in this,
like when they say conscious access, they kind of focusing on like function of the area or the something. I don't know how to say, just conscious access, but they did not mention about the content of consciousness. So when you say like conscious access, there should be something that have access to, for example, conscious access to visual experience, or conscious access to like audition, or conscious access to, let's say, like taste or something like that. But here, the authors try to identify the area important for conscious access, not the content of consciousness. Is that correct?
Yeah. So I think that was their goal specifically, to identify what is the gating process that kind of allows sensory information to be transmitted into all the other regions of the brain, and basically to be evaluated by all these other cognitive processes. So in that way, I don't think it's it is really trying to address what was the content, or how the content may have shaped the access of conscious access. Yeah, but then they also mentioned that the second experiment is more likely to examine, or they actually try to examine the content of consciousness with that. I think it was more about whether the content of consciousness actually leads to a behavioral response that is relevant. I don't see if they were actually able to assess the quality of the face.
So basically what they are saying, that they found region AIC is important for like conscious access, the function, but it does not mean that the area is like plays important role for like some specific conscious experiences. So if you like perceive something, there are some regions for that sensory information in addition to AIC. So that's the their finding. Maybe so from here, if what they are saying is true, by investigating the area AIC, we can find how like brain selects sensory information out of like many input, right? Mm-hmm. So we have, or our body, human body has a lot of sensors like tactile and like visual and audition and blah, blah, blah. And then the AIC like kind of selecting which sensory information should be like in the content of consciousness. So I don't know like how we can like tackle that kind of question from here, but like do you like agree with my like question or idea? And yeah, I understand the finding itself is very important, but from here what can we do is very important.
So as far as I know, in the conscious access of the content of consciousness context, I think the participant, in this study and the context of the content of consciousness, this experiment design is fine for content of consciousness to access, because in fact there is participant can describe face or not, so it is not important for face qualia or variety of the qualia, just it is face or not, and the content of consciousness about face access or not. So it's just so it is not important the other sensory area, visual or audio or something tactile, I think. I don't answer your question, but it is my comment for this design.
Like, yeah, I started to feel like they did not mention that like AIC like kind of receive sensory information and then broadcast it to somewhere or something like that. They just say that activation of AIC is like just related to conscious or conscious access. That's it. So maybe, yeah, talking about the content is out of the interest in this paper, maybe.
I think it's important to remember that the insular cortex and the anterior insular cortex has been implicated in so many other cognitive functions and other functions, such as they also mentioned self-consciousness, emotion processing, interoception, and I think for that reason they propose that this seems to be a hub of all informations, both from the sensory cortices and then also from interoceptive signals to arrive, and then it could be a potential kind of decision maker about what is important, what should be kind of forwarded to conscious the conscious experience. And they also mentioned that it might be saliency that is important in the decision of which information to enhance. But I think after that it becomes quite murky, and I'm not sure like how exactly that information, like how okay, I know that, for example, I understand that we get an instruction and then this auditory information is transmitted, for example, through the anterior cingulate cortex to other regions, but that how will that actually influence the conscious experience itself? I don't think it's examined. I mean, I don't think they were actually set out to do that, but then that remains, I think, unclear for me, if that makes sense.
It makes sense. Yeah, I agree with you. Also, like they mentioned that AIC is kind of or the activation of AIC is correlated with the switch between default mode network and dorsal attentional something. What was it? DAT was stand for?
Yeah, dorsal attention network, I think.
Yeah. Mm-hmm. But like, so I could not check the detail of this paper, but did they mention that there is a like causal relationship between the activation of AIC between the switch? I think they just mentioned that there is a correlation or something. Or maybe in experiment too, they shows that, or they claim that there is a causal relation between them, but I just could not understand this.
Yeah, this was also for me a bit hard to understand because they have examined the pre-stimulus activity of the insular cortex, and then from that they assume that because this pre-stimulus activity was predicting or differentiating between unseen and seen spaces, and because of the bold response supposed to be it takes a couple of seconds to build up, that is why the pre-stimulus activity in the anterior insular cortex may be relevant, like as may be a causal factor in the switch between these networks. But yeah, it is, I think, unclear for me how can it do that and also like what are the limits and yeah, I mean, obviously, no one paper can answer all the questions, but yeah, I think it's definitely like it's an intriguing early result on this, and I mean, yeah, I definitely see that it's worth it to investigate more, but yeah, regarding the causality, I'm not sure.
Yeah, I see.
Yeah, so what they say is that the activation of AIC preceding the switch between default mode network and DAT, the dorsal attentional network or something.
Yeah.
But it does not mean that there is a causal, relationship between them, or like the activation of AIC caused the switch or something like that. So yeah, that part, yeah, I was a bit, skeptical, or I don't know. Like if they found like some strong network or connection between these two regions, or if they can show that the spike from AIC to these networks are found or something, then yeah, maybe we can agree that AIC plays an important role or something. But yeah, I was just not sure. Or I think in the introduction or somewhere they mentioned that they found causal relationship, but or at least where I read, I could not understand why they can say that there's a causal relationship. So that was, a bit unclear to me. Maybe, I don't know, like there's a lot of literature saying that AIC have strong connection to the two networks. But yeah, I was just not sure.
Yeah, I think in the discussion they also bring up the fact that the anatomical structure of the AIC, and specifically that there are these pyramidal neurons that supposedly capable of transmitting information in a longer range. But yeah, I mean, obviously this is more of an indirect supporting evidence. But I do like that they actually mention anatomical structure and how, like, I think it's very cool when studies and researchers are not kind of sticking to a one level of analysis, like in this case, just only looking at network-related activities and only staying in the network framework, but actually also looking at smaller anatomical structures and like specific regions and morphological build-up of these regions. And then you can actually argue in support of your hypothesis, because like based on the anatomy as well. I think that is actually a very, very good practice, or I am hoping to do that in my work as well, eventually, at some point.
Yeah.
Mm-hmm. Yeah, and also I have maybe the last question, but so basically, so when you present some stimuli to a subject, they perceive or they just see it, and then that information will first go to the visual area, and then that response kind of activates AIC. Then after that, the activation of AIC switches the dynamics of networks. Or is it correct? Or so basically my question is that, like, okay, so then what does AIC receive, and where does AIC receive kind of input from? That is my question. Or do they mention anything about it?
Yeah, and also in the experiment too, it is not only the AIC but also DLPOC or ACC or thymus is also activated pre-stimulate. So I think it is the AIC is only the switch function, and your question, my answer of your question, I think the visual area and the higher visual area and AIC. So yeah, so after of the primary sensory cortex to and cross modality and to the AIC, I think.
Mm-hmm.
Yeah, but we also have to remember that so this is an FMRI study based on board response, and it's much slower, and yeah, like so it's we are talking about seconds, and with EEG you would look at milliseconds, and you know how the brain, like these free feedback loops between visual cortices and higher cortices are like it's in the hundreds of milliseconds range, not in the seconds range at all. So I think this approach can be a good indication that there's something there, but you know, actually looking at the exact temporal pattern of the signal coming through, like we are unable to specify that with fMRI. And I think with EEG you have the issue of because these are deeper structures.
Mm-hmm.
Yeah, it's not necessarily that easy to actually look at the activity there.
Mm-hmm. Yeah, I was kind of interesting what the authors are going to do based on these findings. So yeah, I mean, if we can predict that kind of like research or if we can predict the research project, what that other researchers trying to do, that would be like very interesting, or it means that we understand this paper very well. So, but I don't know what can we do from here. Maybe easy fMRI and then source localized the signal, and then test or investigate AIC with a much high temporal resolution. Maybe that's one option. But as long as we stick to FMRI, we need to sacrifice the temporal resolution. So we cannot say anything on top of these findings. Or can we say anything from here? Maybe some functional connectivity analysis, or I don't know. Or what can we do from here? But yeah, that's my last comments. Or given this knowledge, what are you going to do? Or what do you want to do? Or specifically, I think, yeah, this finding is kind of related to global neural space theory, I guess. So Ryoichi, you said that you're interested in the theory and you want to do some experiment on it. So as an psychophysicist, what do you want to do from here? That's kind of my question, not to the author, but to Ryoichi, to you.
Yeah, for me, yes. This is my future direction or something. Yeah. Okay. I'd like to know the consciousness about consciousness on the executive function, like the external perception or something, and also internal perception, like imagination or self-consciousness. So so I want to see the AIC for default mode network, the internal consciousness and dorsal attentional network, like the executive function like consciousness, how to change or how to develop and how to manipulate anterior AIC, how to AIC control the two-dimensional consciousness or something.
Yeah, no, I think this would be interesting, and also I think, or for me at least, I didn't know that because I'm not very familiar with animal brain anatomy, but they mention in the limitation sections that actually the AIC has been only identified in like a couple of, so to say, higher species like elephants or macaques, and where they are able of self-recognition or like similar structure has been only identified in or at least with this type of neurons in a similar area. So in that range, or in that case, I would actually question whether this area is important for conscious access, and whether the anatomical structure is important for conscious access, because I think conscious access must be like, all kinds of animals are able to integrate sensory information and make decisions on it. So just because in humans and in some mammals we have these type of neurons in the AIC, and that seem to work in helping helping information access consciousness. I don't think that is the only way how it could work, and because it's seemingly not how it's working in other animals, then I don't know how important it is actually. Or it would be actually, I would be interested, like this is not an experiment that I could do or a study I could do, because like I said, I don't know about animals. But so I would be very interested to see how, like, what is the brain region of different species that kind of corresponds to this like functional role, and what is the anatomical buildup, and what is the connectivity there, and if we can use this information to kind of predict what kind of sensory information reaches consciousness in that specific species. Because like in humans, it seems to, AIC seem to integrate all kind of sensory information, visual, tactile, and then also internal information like emotions or interoception. And that kind of makes sense because my subjective experience is that, yes, sometimes I'm aware of my internal signals, my heart rate, and also I'm aware of external stimuli. So yeah, it makes sense that a region that kind of provides access to my consciousness integrates a lot of kind of information. And yeah, so I would be interested in seeing how does it work in other species.
Mm-hmm. Mm-hmm. Mm. I feel like, in the paper they mentioned that the AIC is kind of related to self-consciousness, blah blah blah, and also AIC exists only in some like limited species. So maybe like some like animals that does not some animal that do not have AIC may not have like consciousness, or I don't know. Do you think, or do you agree with this, or?
Yes, I don't think I would. I think I would actually say that maybe like, so I think that's actually an interesting question, whether a central hub of control that actually controls so kind of collects all the sensory information and then sends them or prioritizes them to all the other, or sends them to all the other regions. But there is a crucial aspect of consciousness. And I think if we are going down on, or we are going, so if we are checking different types of animals, then I'm sure we will see a lot of different, anatomical solutions for information processing. And by saying that we need this structure just because humans have it, it is kind of like a bit of a egotistic approach of like, only humans have consciousness and this is the only right way to have consciousness. I'm not sure about that.
I agree that it's very difficult to find the corresponding area of AIC in other animals. So maybe just like something similar to AIC is required for consciousness, not the AIC itself, I guess. I think just the hub of networks. I think I asked a lot of questions this time. So if you want to ask something or raise a question, you can please do so.
In fact, many animals have the AIC, but not the bone economo neuron. Is so limited, I think, right?
Maybe. I'm not sure. As I said, I don't know about animal anatomy, but that can be actually.
I don't know, because when you say AIC, what it is, how can we find the corresponding regions? That's a challenging question, I think. So
also, I think mouse and rat have the IC, insula cortex. And how about the insect or something? What?
I don't know.
Me neither. No idea.
Yeah.
So when you say mouse has AIC, do you know how they define or how they confirm that there is an AIC in mouse? As far as I know, when animal researchers try to map the brain regions, they first find some primary areas like B1 or auditory maybe, and then see the relationship between them to find or to define other regions, much higher areas. So in that sense, how can we define AIC? And if they know there are some networks or define, or if there are strong connections between some areas to AIC, maybe we can infer that, AIC is very important. And then this study confirmed that actually AIC is very important for switching networks and also conscious access. So if we know that, or if we have that kind of knowledge, maybe we can feel that, this study is very interesting or something like that. But I just do not have that kind of knowledge. So do you know, so my question is, do you know how rat researchers define AIC in rat brain?
As far as I know, this is an anatomical one, and also the AI. Sorry, I don't know AIC, but IC, insula or intracortex is all. They have intracortex, and it one is an anatomical approach, and also it must have the pain area is also the cortex, intracortex. So the researchers shows the mouse. Yes, that's right. Mouse pain area is also the intracortex. So something to study, researchers to do.
I see. Not only networks or structure, but also I see response to pain.
Yeah,
I see.
Yeah. So I guess if I can have one last question.
Yeah.
How do you think this study relates again? How do you think it relates to IIT? Yes. Do you think, for example, if you would somehow do a lesion or just deactivate the AIC, then that would lead to a significant decrease in phi, maybe? Or what would a hub like this, like a central hub of information, how would it affect the intrinsic information structure of the brain according to IIT? Do you have any ideas about that?
To be honest, I do not know a lot about the anatomy of AIC. So the connectivity between AIC and other areas. But this paper says that AIC is a hub in the brain. And if so, I imagine that AIC is very important to have high big phi, or for brain to have a very complicated integrated information structure. So if we have damage in AIC, then that will cause some serious disorder of consciousness, I guess. But if not, maybe according to IIT, AIC is not important for consciousness, I guess. That's my understanding.
Yeah, no, that makes sense. I think maybe we should look up some lesion studies, if there are some with AIC, because then that would be an interesting addition to this topic. I think I will do that now because I'm interested in this question.
I see. Mm-hmm. Yeah, I'm also started to feel that I need to understand a lot of proposed networks, because in this study, at least I think 7 networks were examined, but I just do not know how they define, or how people define these networks I guess it's based on like functional connectivity and some information on anatomy. But if we understand that kind of like network structure, maybe from IIT perspective, we can kind of predict that some area is very important. And maybe that's an like posterior hot regions, because a lot of like IIT researchers predict that posterior hot zone is important for conscious experience and consciousness itself. So yeah, that's a kind of homework again.
Yeah, no, that's good homework.
Yeah.
So related to the IIT question, I have a question for you. So I think the AIC or intracortex make the moderation of prediction error and the integration. So is it important for it? The prediction error or moderation prediction error it's key for in the IIT or not?
I don't think so. I don't know. Yeah. So the prediction error is kind of mismatch between the like prediction from model and information from sensor. So bottom up versus top down. But I don't think IIT says that mismatch between them is important for consciousness. But maybe what I can say is that kind of, or the region where that kind of mismatch happens will have very complex or complicated networks. At least there's some input from sensory and also from like top down, the higher regions. So that kind of area should be very like complicated in terms of like connection. So maybe that kind of area will have very high or big fibrarity.
Yeah.
Which means, that kind of region can be complex in IIT sense. But I think that's what IIT says. Nothing with mismatch or prediction. Or do you like satisfied with my answer?
Yeah, okay. So I'm wondering if the mismatch or prediction error is high, is strong or big, the more network is required, or so the mismatch is big or means more information or high information. I think, but it is not according to the IIT or your thought, right? It's not a different problem.
I think it's different. So the amount of mismatch is not important in terms of IIT or from IIT perspective. Just structure is important. And also you said that when mismatch is very large, there will be high or large information, but I am not sure whether it's true or not, because the amount of information can be just the same. Let's say, like, I don't know the unit of information, but let's say we have 5 information from sensory and 5 information from higher area. Then in total, we have 10 information, but like each information can be like completely different. In that sense, the amount of information is just the same, but the mismatch is very high. So again, this kind of like the word information should be like carefully used.
I see.
Yeah.
Thank you.
Yeah, I think this was a good explanation.
Yeah. So we talked about the definition of information last time, but again, like it's very, it's easy to use the word information when explaining something. But if you think about what it means, you will be confused and will be in trouble, I think, because it has many information and then, it has many meanings, and then you sometimes like misuse the word.
Yeah, I think that's a wise note to end on.
Yeah, I think we talked this paper about 1 hour. So if you do not have any extra questions, maybe we can wrap up here.